Good afternoon. Thank you very much for giving us this time to offer to you. We talk about aviation as a bad news story when we talk about carbon. It's very difficult to decarbonize aviation. But believe me, there's a big effort taking place in every direction to decarbonize aviation. And over the next 5 to 10 years, you're going to see wonderful stories. And it's not just about fuel, it's not just about aerodynamics, it's about how we deal with materials within an aircraft, how we make them sustainable. The new materials we put into aircraft are straightforward. There's a lot of effort going into reducing the different types of plastics going into aircraft, different technologies, but there's a lot of aircraft are in the sky that have to be refurbished and eventually will hit their end of life. And we have to offer a solution for that. So in 2024, we started a project with Airbus. We're based in Ireland, and our speciality is polymers. We have some experience with waste management, and that's served ourselves very well. It's been very good for us. But we're very innovative, and we don't say that casually. It's a history in our company to do innovative things, to find solutions. We aim, with our business, to make a positive impact on waste, to extend our circularity concepts, and take net zero in our processes as far as possible. This is one great saying. This is from the director from Nike in the States. Waste is simply excess material in the wrong person's hands. Now, we here today, we three speakers would like to say waste in the right person's hands. We know there's a colossal problem with waste from aircraft. After 25 to 30 years, that aircraft is end of life, and we see depressing pictures of aircraft in deserts, particularly in the USA, just dying. And that's not a solution. But actually, it's bigger than that because aircraft get refurbished regularly because they work so hard and they suffer damage. So we have to find that solution. Circularity as a single loop is difficult to do. We can't put waste plastic back into an aircraft too easily. Certain times it may be done, but it's not for general consideration. So we look at the loop in a bigger way. How can we take materials from aviation and put them back into the general circular supply chain? With Airbus, we started this project in January 2024 under a lot of pressure to get this completed quickly, but correctly and with accuracy. So we took sidewall panels. And every aircraft has about 500 kilos of sidewall panel in it. Of course, bigger aircraft more, but typically, say, an A320. And the carpets, can I shock you and tell you that a carpet gets changed every 6 months in an aircraft? And where does it go? Then behind those sidewall panels, you've got insulation blankets, typically made out of a type of fiberglass. And overhead, you've got the light panels. And we all know about the proverbial bins we try and get our suitcases in. And the news now is that every aircraft pretty well is having them taken out and bigger ones going in. So a lot of waste appearing there. And the reason for them doing that is they can get more baggage on board, less frustration, faster turnaround to deal with an ever-growing demand in the market for passenger movements. So we completed our project in May 2024, and Airbus featured us at the Aviation Interiors exhibition to show that they had achieved full circularity. We convinced how we did our work by getting it tested with the National Composite Centre in the UK and 2 academic centres in Europe. And we were able to show that at the end of process, the net zero benefit was 1.7 tons. And how the hell do we do that? Excuse my expression. The base material on this is packaging waste. 70% of this material is packaging waste that would normally go for incineration. Divert from that, and you're avoiding about 2.7 tons of CO2. The products we make are for the construction industry, and then again, we're replacing high-carbon products. So this is a way to decarbonize the world a little bit more, quite a lot more. So I'll show you a video here of how our process works today.
Welcome to Plaswire, where innovation meets sustainability. The RX polymer processing begins as cabin end-of-life waste arrive at our state-of-the-art processing plant, delivered by our dedicated logistics partners. All materials are weighed and tagged with a unique QR code, ensuring precise traceability throughout our process. Utilising cutting-edge techniques, we process the cabin end-of-life waste, size reducing and separating out the material fractions, maintaining the individual QR code identity every step of the way. Granular mixed material is formulated into Plaswire's RX polymer and processed into the finished polymer products, moving this complex material into the circular economy. Versatile and sustainable products. Our outputs: solid, eco-friendly, fully recyclable products, bearing the same QR code for seamless traceability. At Plaswire, we're not just repurposing cabin end-of-life waste, we're revolutionising sustainability in construction, manufacturing and beyond. Be our partner to a net zero future. Plaswire. Innovate, repurpose, sustain.
Thank you. We are specialists in the wind sector as well. We're the only company in the wind sector that can recycle a wind turbine blade. So there's a lot of pressure on us to grow our business and do great things for everybody. So today we make extrusions. We make extrusions that can be used for furniture. We make wood replacements. We make precast concrete replacements. And for the airlines, it's a benefit. We've got a new model for them where they can actually do something sensible with their materials and not send them for landfill or for incineration. And it reduces their overall costs. For the benefit for the passengers, they can feel confident that the airlines they use that allow them to enjoy their travel are dedicated to doing the correct things. And of course, there's the environmental benefits. So our 1.7 ton CO2 saving is actually an understatement because we've increased our capacity. For example, that's an extrusion we do with 30% aviation waste in it. 3 months ago, we could put 10% in. So our concept is relatively simple. Of course, it's not simple inside the factory, but it's to bring the materials into the factory, process them, manufacture product, and then take it back again. The industry, the aviation industry, is taking back our material already, and we're working on projects with Airbus that will serve them within their logistics system so they can take back their own material, reuse it, circulate it, and should that material get tired, need replacing, we can take it back, we can recycle it. We offer the product with a QR coding on it, which can even say where the aircraft filling came from. And that allows people then to see it's genuine, and it gives instruction on how to recycle. Thank you very much indeed.
Thank you, Andrew. Do we have any questions? Yep.
Thank you for the presentation. I just had a quick question. You say that you have a QR code that follows the product from the waste. Does that mean that you are not actually mixing the wastes? Can't you imagine that you have two sources of waste that at the end gives one product?
This product here has a minimum of 8 wastes in it. And we have a patented technology called RX polymer, which has demonstrated that we're able to mix plastics that you would not normally be able to mix. That's the way we were able to start diverting waste from incineration, starting to reduce that CO2 production.
Okay, thank you.
Any other question for Andrew? No? Okay, thank you. So we're going to free you. Thank you, Andrew. You can always come to Andrew later to ask any question. Thank you.
Thank you indeed, everybody.
So the next speech is from Lionel Leroc from Tarmac Aero. Yes, please, you can applaud. Yeah.
Well, good afternoon, everyone. Well, it's a pleasure first to be here. It's a pleasure to have a panel really on circularity. You know, in aviation, we talk about sustainability, we talk about emissions, we talk about all of that. Very interesting to see at the end of life what is the reality of what we can do. And in Tarmac Aerosave, from almost 15 years that the company is existing, there is really in the DNA of the company the fact that we want to have a proper recycling of every aircraft at the end of life. So Tarmac was created some 15 years ago. It's a common company between Airbus, Safran Aircraft Engines, and Suez. The important part of that is that since 15 years ago, there is a real focus in the end of life. It's not overnight thinking, it's not something new, it's really something that we are committed to. And we've got basically three activities in the company. The storage of aircraft, and through COVID, we received more than 200 aircraft and redelivered, we received, 700 aircraft and redelivered 600. We're doing maintenance, but at the core of it, we're doing recycling. So we've got three facilities, two facilities in France, one facility in Spain that is dedicated for aircraft recycling. So why the hell would you recycle an aircraft? Well, there is many reasons, and the first one, at the end of service, the aircraft still have a lot of value in terms of components. So the reason that you retire an aircraft at 20 years is that very likely you will have the engines, you will have the landing gear, you will have a lot of parts as avionics that still have value and that can continue flying. And this first step will be the dismantling. So we will remove all of that from the aircraft. And basically this is very circular, because these products, those components, will continue flying on a new aircraft after proper maintenance. And that is very important that we're able to capture that. This is quite easy on components because aviation is all about traceability and components and airworthiness. And because of that, we've got full documentation and paperwork about that, and we can remove those components when the aircraft arrives with us to put that back into the market. And we're talking about a third of the weight of the aircraft that will be directly put back into flying. But what about the rest? And the two-thirds then comes to the question of what do we do with the rest? What do we do with the rest, which in the end is a waste? So you're talking about the fuselage and all of it. So you might have seen on some pictures or in the past some aircraft that are either abandoned in the desert or some aircraft that are just simply crushed together and put to landfill. And that's not the choice we made. The choice we made was to say we've got a responsibility to that, and how can we feed the market with proper material? The way to feed the market with proper material is to segregate everything from the aircraft from the beginning. Basically, we are sorting like you do at home. You finish your pot of jam, and you separate the lid in aluminium from the pot in glass. And this is exactly what we do in Tarmac. So what we do is that we are going to segregate and separate everything from the aircraft. So name it composite materials, name it plastics as you saw. And then at the end, we're going to leave with only the fuselage, and we're going to cut the fuselage and recycling the fuselage properly. What does it mean to recycle the fuselage? Well, it means collecting the aluminium. But up to now, the aluminium that we could collect was aluminium that going back into the market to produce maybe one of those chairs or some of these mic. And that was not really interesting in terms of circularity, because we had a very high engineered product that was not able to go back into the industry. And so there is really something really strong that is happening now, and that we're very happy to present in Le Bourget, is the fact that now we're recycling in a closed loop. Let me show you. So as I said, we start with the structural disassembly of the aircraft, and we are going then to segregate all the materials. Based on that, all the aluminum that we collect will be shredded and pre-processed, decoating because there is a potential pollution in that, and then sorting properly. The reason we do that, we're able then to be able to remelt and cast a new ingot with extrusion, and there it can go back into a new aircraft. So that's the first time that it is presented in Paris Air Show, a closed loop, a circular loop in aviation material. And this is with the first ingot that is presented, and you've got one here on the left, one here on the right, that is presented today. And that was possible to be done with material that was collected at tarmac, and material that was then melted and sorted, segregated, and treated by Constellium, which is very strong in material. And this first is highly important because we can prove that it works. And we can prove that not only we can collect aluminum, but also we can put back aluminum into the system at aviation level. And you can see on the ingot 2024 alloy. So it means that this aluminum have got exactly the same characteristic as a raw material, an initial raw material. So this is the second life raw material that can be then again an aircraft directly. And that is the first. We're very happy to show that this is possible, that the proof of concept is here, that the first ingot are produced, and to start the circular program. That works with aluminum. Today, A320s, 737s, 777s, A330s are mainly aluminum aircraft, most of 70% of the aircraft. And this is the aircraft that we recycle today. And this is the aircraft that we will continue recycling in the years to come. So this is very interesting for the aluminum, but this is also very interesting for the other minerals and materials that there is in the aircraft, namely titanium, namely copper, and all the other metallic elements. But as Andrew said, this is also now possible for plastics, and we announced also with Torre that we can do that for reinforced plastics in the aircraft and thermoplastics. So as a first today, we're very proud to present these ingots, and it's not a concept, it's not an idea, it's a reality of what we can deliver to the market with a proper closed-loop circularity.
Thank you. Thank you very much, Lionel. Do we have any questions?
There.
Oh yeah, it's always behind me.
Thank you. You just showed the possibility of having no degradation in terms of properties. So this is very interesting, and for metallic parts, it's something that has a lot of future. In terms of composite materials, there will be more and more composite materials in the aircraft going into waste. Do you also have opportunities and projects ongoing around the recyclability and circularity of composite materials?
Well, that's a very fair question for the future. We've been doing this job, and we've done 450 aircraft to date, okay, in terms of recycling. Basically, those aircraft were designed years ago, and this is mainly aluminum aircraft. And this is aircraft where aluminum is a majority. But tomorrow, it won't be there. So today, we're treating that, and it took that time to be able to produce that ingot. We also have a difficulty is the volume. Because also I'd like tarmac to capture all aircraft in the world and recycle them. Aircraft are everywhere in the world. So this is a global challenge. And the regulation everywhere is also different to do that. So back to composite material, you've got very different composite in the aircraft, and we're moving to the next generation of aircraft, 787, A350, where the carbon fiber and CFRP are much more higher. And today an aircraft is 70% aluminum, very little composite. In the future, it's 70% composite and very little aluminum. So yes, there's things starting on that. I would say that we are at the technology level. We're not at the industrial level. We need to get there. But as Andrew said, there's means and ways to do it. The big difficulty is first do what we have today and get ready for what we have tomorrow. The fair point in that is identification. We need to know, if we want to treat things properly, to know what is in the aircraft. Today, an aircraft flying is basically a worthiness and the safety about the aircraft. And all an aircraft is thought around safety. But if you want to recycle properly, you also have to have a proper, let's say, material passport or a bill of material that you know what you get at the end. What type of composite, what types of encapsulating of composite, what types of composition. And to be able to do that, we need to work also all together on that. So Tarmac is member of IAEG, to make sure that we work together on those subjects, together with the OEM, but also with people that, like Andrew said, are able technically to do it, because Tarmac will segregate, but segregate to the need of the recovery channels.
Thank you.
Thank you. Do we have another question for Lionel? No? Okay. Thank you very much. You can go and discuss just after the pitching session. Thank you, Lionel. I think we can applaud you again. We are going to now switch to French. So the next speech is in French, and also we won't have questions because if you want, you can just go behind you, the booth behind you, and ask them all the questions, and they can show you everything. So let's welcome Gérald Cotta and Gérald Millet from Safran Seats. Bienvenue, je passe en français, du coup le prochain pitch est en français.
Yes, it will be in French, but for the demo it could be in English if you are interested. So I switch to French. Bonjour à tous. Donc, si vous avez eu la chance de venir déjà sur certaines de ces conférences, vous savez que la décarbonation, c'est un des piliers de la stratégie de Safran. Vous avez pu avoir des exemples sur les moteurs, vous avez pu avoir des exemples sur les carburants. Nous, on va maintenant parler d'intérieur d'avions pour lesquels Safran est leader mondial. On va parler d'intérieur et plus particulièrement de sièges. Et comme ça vient d'être dit, on vous montrera, pour vous montrer physiquement, grâce à la maquette Circle qui est juste derrière vous, que Gérald évoquera dans la deuxième partie de la présentation. Et avant d'aller plus loin, je vais passer la parole à Gérald qui va donner quelques exemples, enfin qui va donner la vision globale et quelques exemples de ce qui sera sur Circle. Mais encore une fois, si vous êtes vraiment intéressé, je vous invite après et les jours suivants à venir nous rejoindre sur la maquette qui est juste derrière.
Merci. Oui, donc un peu de détails sur la vision Safran Seats pour la circularité et pour l'allègement, qui sont des piliers vraiment de la stratégie Safran. Donc en fait, on a des solutions sur l'ensemble du cycle de vie qu'on peut voir ici. Notre vision, clairement, c'est un siège plus léger et plus circulaire pour 2030. On va retrouver ces deux phases sous l'appellation Rebuild pour la première, où là, clairement, ça va être la circularité et l'utilisation des chutes de production pour recréer des nouvelles matières qui va être un des fondements. Pour la partie utilisation, donc pour réduire notre impact, ça va être vraiment l'allègement, le point principal qu'on va améliorer. Et ces deux piliers-là, on va les retrouver directement sur le démonstrateur tout à l'heure. La deuxième partie du cercle, finalement, est très importante. On va retrouver l'extension de la vie active, donc de l'usage. Ça, c'est vraiment un fondement de l'économie circulaire forte. Il faut augmenter l'usage du produit pour diminuer son impact. Donc là, on a des solutions aujourd'hui avec le programme Seat Life qu'on a présenté il y a quelques temps. Avec Seat Life, on va étendre la durée de vie du produit en proposant des solutions de réparation de nos sièges et en proposant aussi des kits pour une remise à niveau des sièges pour éviter l'obsolescence des sièges et donc qu'ils soient débarqués pour un problème d'obsolescence technologique ou obsolescence en termes d'attendu client. Et la dernière partie, c'est quand on n'a plus d'utilisation du siège possible. Dans ce cas-là, on va essayer d'optimiser au maximum le recyclage en essayant de garder la valeur de la matière. Ça a été expliqué très bien juste avant par Tarmac. L'idée, c'est de garder justement l'application aéronautique et de pouvoir justement garder le matériau pour son usage pour lequel il a été finalement créé au départ et ainsi éviter une extraction matière pour créer des nouveaux matériaux. Donc ça représente effectivement toute la vision Safran Seats pour 2030. Et pour supporter cette vision, comme je l'ai dit, on a le démonstrateur qui est derrière vous qui s'appelle Circle. Et sur ce démonstrateur, on a intégré 15 technologies. Donc ces technologies, comme j'ai dit tout à l'heure, elles sont sur les deux premières étapes finalement du cycle de vie, pour Rebuild et pour Light. Pour Rebuild, on va trouver un certain nombre de technologies qui vont être très intéressantes. Par exemple, on va avoir la console du siège. Donc la console, elle est finalement issue de nos chutes de production. Ces chutes de production, on va les récupérer durant notre process de fabrication. Et on va finalement les réutiliser pour créer un nouveau matériau. Et ce nouveau matériau, on a pris le parti pris de finalement mettre en valeur la problématique technique qui était initialement sur cette thématique-là. C'était les différentes couleurs qu'on pouvait avoir en termes de plastique. C'était une contrainte, qui était une contrainte pour le recyclage. Et pour faire quelque chose de ces matières, parce que c'est impossible de trier vraiment par couleur précisément. Donc finalement, on a fait, vous verrez tout à l'heure, j'espère si vous venez, un effet un peu marbré là, qui apparaît en travaillant avec nos designers pour créer des motifs qui finalement ne cachent pas d'où vient le matériau. Oui, c'est un matériau recyclé et on le met en valeur. Donc ça, c'est pour la console. Avec Rebuilt, on va avoir aussi un certain nombre d'autres technologies plus orientées allègement, comme j'ai dit tout à l'heure. Et là, pour l'allègement, une des choses qui est très mise en valeur avec la maquette, c'est la fabrication additive, qui est complètement aujourd'hui pleinement maîtrisée par Safran et par Safran Site, notamment la fabrication polymère qui est sur le siège aujourd'hui. Donc on va, grâce à la fabrication additive, fonctionnaliser des pièces, simplifier des designs, profiter vraiment de ces nouvelles libertés qu'offre la fabrication additive pour alléger les structures, créer des nouvelles structures plus légères, et c'est vraiment quelque chose de très intéressant pour nous. On le retrouve à différents endroits sur le siège, des petits bumpers sur la console et puis sur le pied de l'ottoman, sur la lampe, et effectivement aussi sur le pied d'ottoman, on a de la fabrication additive métal qui va être aussi présentée. La fabrication additive métal est d'autant plus intéressante quand on la couple à des logiciels d'optimisation topologique qui vont permettre de vraiment pleinement profiter des libertés qu'offre ce nouveau procédé et de vraiment libérer des designs, d'avoir des formes assez organiques et vraiment de faire des gains masse assez importants. Voilà, après on va avoir un certain nombre d'autres technologies et notamment des technologies qui permettent de gagner sur les deux tableaux.
Effectivement, Gérald vous a présenté des solutions pour gagner de la masse, des solutions pour augmenter du recyclé. Dans certains cas, on essaie de faire les deux en même temps, en utilisant une matière de recyclé à partir d'une autre matière neuve, ce n'est pas la même. Notamment sur nos composites, on utilise beaucoup de fibres de verre et nous tentons de recycler de la fibre de carbone qui vient du groupe. Donc c'est un projet qui est au niveau du groupe Safran, pour utiliser de la fibre de carbone. Donc on fera à la fois du gain de masse grâce à la performance du carbone comparé à la fibre de verre, et en même temps, on achètera moins de matière neuve en termes de fibre de verre, et on aura moins de déchets de fibre de carbone. Voilà. Encore une fois, on vous invite tout à l'heure ou sur les prochaines journées à venir voir la maquette qui est juste derrière. Comme ça, au-delà de ce qu'on dit, vous verrez physiquement, vous pourrez voir et toucher. Merci beaucoup.
Thank you, Gerald and Gerald. So,